Yep. Thank you. Yeah, whatever point, if you have any questions on any of this, leave them in the chat, and every now and then I'll be stopping to pick some up, although I plan to have some Q&A towards the end. Philippines, Mississippi. I see Mississippi with the Mamba Kraken. That's awesome. Canada, Toronto. 6:30 a.m. in India. Good morning, GM. It's 8:30 p.m. 8 p.m. where I'm from. Singapore. That's so cool. Okay, we got people from everywhere. That's one of the cool things about Discord and communities. Honestly, it's people all over tuning in as long as they have an internet connection. Good morning from India. Good morning to you. Very cool. Let's see how many people we have connected. I don't know if we have a count, but it should be around 20 from what I can tell so far. Morning, morning. Wizard Pepe. Hyped about this webinar. Glad to see. I hope you learned something, just one thing. If you learn one thing, that'll be the only thing really that I take away from this. Michigan, nice. I don't know if to say go blue or go Spartans, but one of those two probably. Cool. It's 8. We'll still give a couple, 2 to 3 minutes for people to trickle in, and then I'll get started. I'm recording this anyways. We'll probably send some version of this afterwards or some snippets. I don't know. We'll see. But cool. Today the agenda is the etherscan.io, which you'll you have all probably been there multiple times. Maybe there's some numbers there that you don't really understand, and my goal is to explain some of that, or how I understand many of these. Again, I'll just wait a couple more minutes before starting, just if anybody's coming a bit late, so that they don't miss anything, especially to start. I have the chat open here to my left, so I'm kind of monitoring, but as I start, I'll probably not look at it that often. Again, if you're new joining, let me know. I'll be monitoring the Kraken's chat where everybody's posting hyped. So if you're here, you can be there as well. I don't believe you have to be inside the event. I think you can minimize it and keep on chatting. And that's really the goal, or whatever you want to do. Welcome into Any Kraken. Yeah, okay, cool. That's what I thought. Hang around Discord, the community, listen into the stream, maximize the window if you're really interested. For certain pieces, if you're not, just minimize it and be there in the chat. That's what it's all about. Fuzzy Gang Caso asks where I'm from. I was born in Venezuela and lived there for almost 20 years, and I'm now in the US, living here and working here. Thank you, my friend. No problem, my friend. Okay, cool. We're gonna get started. Awesome. Okay, so from now on, I won't be monitoring the chat that often. I'll just pause for questions and open every now and then. Thank you, Krakens, for joining in, for tuning in from wherever you're from. I know we have every part of the world, the U.S., India, Philippines, everywhere really. So it's really exciting. And we're all together here for one reason, I guess, which is to learn about an Ethereum transaction, and we'll break down a lot of the data that an Ethereum transaction contains. So by way, I like to do things by way of example. So I'll be here, clicking on things, zooming in, trying to explain some stuff in my screen. So if you want to take a look at that as I'm explaining, that'll probably give you more info. So Etherscan is a block explorer for the Ethereum blockchain, as you can probably tell. So you can scan whatever piece of the Ethereum blockchain you really want. Ethereum blockchain is, or any blockchain by design is open source. Every single transaction is registered. You can see here latest transactions coming in. If I refresh this, probably more transactions coming in. So everything is public. Um, but a lot of data is a bit nuanced, hard to understand. And my kind of goal today is to clear a lot of things up. Before I get started, I'll just share a bit about myself and my background very briefly. Mostly you can mostly find me on Twitter, Daniel Belfort. I just recently opened up this account, but I am sharing some ideas that I'm thinking about, mostly around digital scarcity. The whole premise is that with blockchains, anything in the digital world can be made scarce. Before we didn't have that option. And it's easier to understand what scarcity is, because if you live in the physical world, everything kind of by nature is scarce, is limited in a sense. Time's scarce, the desk that you have is scarce, that's why it costs money. And water scarce, that's why you pay for it. And so kind of supply and demand act on scarcity, and now supply and demand are acting on digital scarcity, which is kind of a new concept. As I was saying earlier, I'm from Venezuela, and currently I'm working on the engineering department of Procter and Gamble, which is a Fortune 500 company. And here in the US, I design applications for them. And if you're interested in some of my essays and thoughts, mostly on like crypto and life, you can take a look to some of the ideas here. They're pretty fast to read. Anyways, if you're interested, you can do that afterwards. Um, cool. So let's go on Ethereum transaction. Last time that I did a webinar like this, I went to a Wales address, a guy with a lot of Wales, a guy with a lot of wealth, and then in the crypto world. Pranksy is a notorious whale in the Web3 world. And if you want to see who Pranksy is, I usually just go to OpenSea and search for Pranksy, and you can see this whale's amount of NFT that he holds. He has 32,800 NFTs, has been in the game for I think more than 4 years now. So he's just an Ethereum whale that just has a lot of activity in the Ethereum blockchain daily. And the guy just minted, I don't know, 40, 50, 100 of these 17 minutes ago. Anyway, so let's look at Pranksy's wallet. So I just searched for Pranksy, and he currently has a balance of almost 1,000 Ether, and this amount of value, and he has all these tokens. Again, everything's public, so you can really inspect any wallet address that you want here. But this webinar is mostly focused on the data that goes into a transaction. In Ethereum, you can do a lot of things. You can mint, you can transfer money, which is a transaction. You can write to a contract. So here, transfer, mint, multi-call, so a bundle of things in one transaction. So there's really a lot of things that you can do. One function is a transaction. So if we just scan through Pranksy's activity, we're just gonna click into a transaction that looks attractive or that catches my eye, which is this one. So he sent 25 Ether 2 days ago from his address to this other address. So let's click on the transaction details and really see kind of what's going on under the hood here. So this is kind of the page that we'll be exploring. Firstly, so we'll be exploring the 25 ETH sent from Pranksy's address right here to this other address. And we could go into this other address and see the activity of this other address, but that's kind of for another day, or if you want to do it on your own. Each transaction in the let's just start from the top. Each transaction that an Ethereum uh, each transaction that goes along in the Ethereum network or blockchain has a transaction hash associated with it. A transaction hash is only a unique identifier of the transaction, so it just numbers the transaction. Um, so if I see here is a unique 66 character identifier. And this is 66 characters, and theoretically, um, every single transaction on the Ethereum blockchain has a different transaction hash. So who really determines what a transaction hash is? And we'll be exploring kind of just very high level what the algorithm is that generates this hash. But in essence, um, a transaction has a lot of inputs, which are a lot of these that you see: block, timestamp, from, to, the value sent, the fee sent, the gas price. All of these are inputs for this transaction. And there's an algorithm called KCHAC 256 that we're gonna cover briefly, that grabs all those inputs and blends them. And imagine a Rubik's cube. The algorithm, using a lot of math and cryptography, modify those inputs, and the output in this case is the transaction hash. And then the algorithm has kind of the design that no two single set of inputs produce the same output hash. So every transaction hash is unique, as long as just one input in any of these things provided are not the same. So if we quickly, as I have pulled up here, kind of this KCHAC 256 cryptographic algorithm that Ethereum uses, and I'll input, in my case, I'll just put hello here. You can see how this set of inputs that I'm putting here, putting it through the encryption algorithm, outputs a list of 66 characters. And one neat thing about this algorithm for security reasons is that the hashes outputted from slightly different inputs are way different. So if I just even add a space to hello, you can see the entire hash output changes. If I add another space, it changes again. If I put hi, it changes completely. If I add an exclamation point, it changes completely. So that, for security reasons, is very important. There's no really way you can predict a hash by just knowing almost the set of inputs. So it not only maps uniquely, but it maps very differently, even if one or two characters are different. So you can see how this widely changes with any sort of input. So that's KCHAC 256. If I go to Ethereum's code, and I'm kind of laying all this out so we can just return back to these inputs and see how they all tie in. But this transaction hash comes from, and I will go to the Ethereum code here just very briefly. You can see that there's a transaction data variable that takes in all of these parameters. So to produce that transaction output, you need to input gas price, what the gas tip to the miner was, what the gas fee is, things that you can find here, gas price. This 25 ether is the value. So you can see that you have to pass in the value. Nonce, which we'll get to, what's the address that this is using. So all of these inputs go into a transaction. This transaction goes through this algorithm, maps it to a hash, and that hash is this one you see right here. And so kind of one of the inputs is block, which is where this what block this transaction was mined into. We can see here that 2 days ago Ethereum was on the 14th million block, and there's already been 13,000 blocks mined after that. but this precise transaction lays on this block, and a block is just a set of transactions piled together. We can even see we can inspect this block and see that there's 300 transactions in this block. And this prank transaction is there, so that's input. And when it was executed 2 days, 2 hours ago, that's also input. Who sent it, Pranksy, to who, this wallet address. So these are all inputs that go into making what a transaction is. Value, so if you're minting, that's the price of a mint. If you're sending money, that's how much money you're sending. In this case, 25 Ether was sent. And this is the current value of those 25 Ether, which is almost 80K. But you can click here and see what the value for that transaction was at the moment of making the transaction, which is 2 days ago. So that varies per Ethereum's price point. And then we can see here the transaction fee. How much did Pranksy or this wallet address pay to send these 25 Ethers? And kind of what I'm going to explore right now is we're going to mostly stay here on this transaction fee because a lot goes into determining these $4.81. Precisely what was the gas price at that moment, what was the Ethereum price at that moment, gas limit, gas fees, burnt transaction fees, etc. This entire section goes into putting into forming this transaction fee, and all these inputs are also things that go into making up a transaction. So I've covered quite a bit there. What a hash is, KCHAC 256, seen a bit of the code and what goes into a transaction. I'll just monitor the chat real quick before I get into kind of the nuances of what goes into a transaction fee. So I'll stop there just briefly, probably for a minute. I don't know if there's any questions. Baby crack and let me know if you've heard anything. If not, we can just continue. Okay, cool. Yeah, there's a question, what is nonce? I'll get to that. We'll get to that, and that's one thing that goes into what makes up a transaction. And nonce is basically the amount of transactions that a wallet has made ever. So in this case, 59,000. It's used mainly for security reasons. One way is to prevent a same wallet address from sending two transactions with the same nonce to prevent double spending. So never again could this wallet address send another transaction with this nonce. It's just put there. It's just reserved for this one. And then I'll cover what position is. Yeah. Well, so the nonce number is unique to that wallet address. So if there's another wallet address that has had 59,027 transactions, it will have the same nonce. But note that it's a different wallet address having that same nonce. What can't collide is the same wallet address with the same nonce. It's just a way to identify each transaction that a wallet address has had. Cool. Let's see. I think we're good to. I hope that explained it. So one nonce to a transaction. Every transaction has the next transaction that this wallet address had was 59,028. And the next one was 59,029. So yeah, a nonce just is an increment of every transaction a wallet address has had. Cool. The transaction there's a lot that goes into a transaction fee. Even though it's kind of $4.81, and this may not seem like a lot, there's a lot of complexity to it, as you can see here. It's also part of this goes to miners validating nodes, running nodes, and validating transactions. So part of this transaction fee goes to miners, and part of it is burnt. We'll cover what this is, but there's kind of all these inputs that go into actually determining what the fee was for that transaction. First one, which you've probably all heard before, is the gas price. We always hear about, I don't know, gas price, guys, gas price is high. I'm just gonna wait until doing this transaction for gas price to be a little bit cheaper. So we're all familiar with it. And it's essentially it's nothing we can control or the users of the network can control. It's um it's the incentive that miners have to mine your transaction based on the current demand for transactions happening in the Ethereum blockchain. So if there's a lot of people connected to the blockchain and wanting to make transactions, that's a lot of demand. So you have to pay a bit more for gas to get your transaction through and validated. So there's like different times and different days where gas price is usually lower or higher, and based on just normal work hours or activity. Um, and for every transaction, you need certain amount of gas for it to go through. And that amount of gas needed depends on that transaction because every transaction is different. If you're minting from a contract, that's gonna the gas that you're using is gonna depend on how sophisticated that contract is, how many functions that contract has to run to validate whatever you're doing. If it's a mint, how complex is that mint? If it's just that transaction sending money from one wallet to another, or sending Ethereum from one wallet to another, it's I think always 21,000 units of gas that you need. So you have to pay for 21,000 units of gas to send money from one wallet to another wallet. Um, so if a car is here and needs to go to the point B and point B is sending money to another address, you need 21,000 units of gas to get there. And then gas, as I was just explaining, is the amount of demand. So, and it's usually expressed in GUI. GUI is, so this is the amount of ether that gas price is currently, and this is the amount of GUI. If we just convert, you can see here that one ether is equal to these amounts of GUI. It's one with 9 zeros afterwards. Um, and so literally just a transaction fee is your gas limit by your amount of GUI. So this is how much it costs to move 1 unit of gas. This is how much gas you need to move the entire thing. And if you want to convert those from Ethereum to dollar, you just use Ethereum's price point at that moment. Again, you need 21,000 gas. One gas is equal to this much, which is a very small amount of Ethereum. So 21,000 times this number is this number up here, which if you want to convert to dollars, you just multiply by this, which Etherscan already displays how much that is. So that's what goes into a transaction fee. And so this is the gas limit, and you can see usage, gas usage. And there's some cases where you use less the amount of gas that you need for some reason. I don't understand that. But in this case, all the units were consumed. So that's what goes into this transaction fee. And then you have kind of these gas fees right here. You have base, max, and max priority. And for me to explain that, it's important to understand that this transaction fee, $4.81, some of that was burnt and some of it went to a miner as a miner tip. So a transaction fee is how much goes to a miner and how much is burnt. Okay, and this is actually a relatively recent change in the Ethereum blockchain. This is called the London hard fork, where before nothing was burnt, I believe, and now it changed to and base fee and tip. So if we Google London hard fork, it happened in August 2021, where Ethereum implemented the Ethereum Improvement Protocol 1559. So the blockchain forked and went into another chain and keeping the previous change, but now implementing a new protocol, which says of the entire transaction fee, some of it we're going to burn, meaning we're just going to eliminate that currency from the network, and some of that is going to go as tip to the miners. And you can see here the fee was $4.81. You can see that $4.67 was burnt, and then the difference you sent to a miner. And what's this line here? Base, max, and max priority. The base, the base fee you can't determine. It's based on the network. So you minimum have to pay a gas fee of 70, but you paid 72. The base, it's what's burnt. So almost, I don't know, almost 90% of it or more was burnt. But then the difference between how much you paid and what the base was goes to the miner. So you can see that 2, if it's the difference between these GUI and these GUI, and you can see that 2 went to the miner. And so how do you determine, again, going back to this diagram, how much is base and how much is tip? It's a formula where it's the minimum of, I think, minimum of max minus base, and priority. So give me just one moment here to lay this out. So this is the amount that goes to the miner. You find what's the lowest of two numbers, max minus base and priority. And whenever you're making an Ethereum transaction, max and priority you can choose. You can modify, base you can't. So max is the most amount of GUI that you're willing to pay for this transaction. In this case, it was 84. Usually MetaMask determines that for you based on network activity and to make it simpler to make transactions. So the difference between what you most were willing to spend and the base, which you can control, is 1484 minus 70. And then the priority you also set, and then in this case, it's usually set to 2. So what's the lowest between 14 and 2 based on this formula? And that's 2, and that 2 GUI is the miner tip. In this case, it turns out to be 14 cents, which is the difference of how much you paid total versus how much you burnt. 14 cents went to that miner. And this transaction savings here that you see is if you were to have paid these 84 GUI instead of 70 GUI, how much would you have paid, which is 79 cents over what you actually paid. So that's the amount that you saved. So just to recap, this space you don't control based on network activity. Max and max priority are two inputs that you can control. Usually MetaMask auto determines that for you to make it simpler, but you can go to, I think, advanced options and change that. And so there's a formula that EIP 559 protocol uses to determine how much of that goes as miner tip, which is the minimum of the difference between max and base and max priority fee, which in this case, we went through the exercise, it's 2 versus 14. And so just to close the thought there, you'll notice kind of strangely, and you probably know that there's currency being burnt in the Ethereum blockchain kind of per every transaction made. And that's why it's called usually the Ethereum currency, or Ether to be more specific, is called super sound money because as time goes by, the supply of Ethereum decreases with time. And so that makes it decreasing in supply. Usually, I guess, if demand is the same, that elevates the price per Ethereum. But that's kind of a neat thing about Ethereum. Bitcoin, for example, is a capped currency, so it's sound money, where there's only 21 million Bitcoin ever to be made. I think we're more than 90% there, or mined, sorry. So there's only 21 million. It doesn't decrease, it doesn't increase. It's hard. It's in the code that there's only 21 million. So that's the difference between Ethereum and Bitcoin, like currency caps. And then you have other currencies, kind of traditional fiat, say the US dollar, where there's no cap on supply. There's the Federal Reserve Institution that, if they want to print money, they can. So they devalue, the unit of dollar as supply increases. So you have currencies without cap, with cap, and with decreasing cap. So that's kind of an interesting thing. And how much Ether is burnt per transaction, you can quickly see here that it's 0.00147 Ether, which is almost $5. So that's kind of deconstructing the Ethereum transaction fees, what goes into this ultimate number here that you pay, that we all pay for any transaction. And again, all of these variables go into making up an Ethereum transaction. And if we look at the code, and so we put all of this data for a transaction, put it through this K-check 256 algorithm, it gives us our transaction hash, which is up here. Cool. Kind of next part of this, next to last is, well, I guess I'll cover what these three are, and then I'll leave the input data for just a little bit. So this is telling you transaction type, and it's telling you that we're using the EIP 1559 protocol, which I kind of explained here, and we saw in the London fork. Nonce, as I covered before, is the amount of transactions that this wallet has made. So it increments per every transaction by one. And position is just where this Ethereum transaction is in the block that it was mined. So it's 196. And if I go to the block that it was mined, this block has a total of 340 transactions. And this transaction is the transaction number 196, which is probably a bit closer to the middle, somewhere here. But that's what nonce represents, just where in the block, in what order in this block was it mined. Cool. I'll stop there just for a little bit. Check chat. How are you guys doing? Any questions you might have? Gwei. Oh, nice. Is a blend of Giga and Wei. Yeah, all these unit conversions are pretty interesting, actually, as a fun fact as well. You see here a couple of conversions from one Ether. There's a Fini, which 1,000 Finis is one Ethereum, and a Zabo. Um, a million Zabos is one ETH, and actually these are named after Hal Finney and Nick Szabo, which are like two pioneers in modern cryptography, so they're named after them. So if I go here to Hal Finney, he passed away in 2014, but he's a cryptographer, and then you have Nick Szabo, computer scientist, geniuses. They've named unit conversions after them here in the Ethereum blockchain. Yeah, pretty cool. And this you can see if you go to etherscan.io. /unit converter. You can see, you can also find it here, Etherscan more unit converter. That's how you get to this. And I'm very glad, Krakens, that you're liking this. And thanks, Fit Mob Glam. Awesome stuff. And thank you, Wizard Pepper, for helping me out here with. See you answering some questions. Thank you, thank you, thank you. That's awesome. And this topic excites me. That's so cool. And me too, as you can probably tell. And this is very at the forefront of a lot of development that's going on in the financial industry, obviously with NFTs, and just a lot on the decentralization front. So really important to understand what a lot of this all is. And I still need time to digest this. This takes a lot to digest, and if you've never heard a lot of these concepts before, your brain's probably um going nuts or going insane. But I don't know. You can rewatch this, figure it out on your own. Go to etherscan.io and just poke around a lot of this. And probably Google around, and then you'll I'm sure you can figure it out yourself. Cool. Let me finish up with a couple of things. Um, Input data, you can see that kind of we've covered all of this, all of these fields. I think all of them, yeah. Last one is input data. And what this is basically alongside any transaction that you want to make in the Ethereum blockchain, you can also add some data yourself, some input for another person to read. Um, And so this is displayed in hexadecimal. Um, so I think I'll explain this by way of example better. So I'll just send a transaction to myself with some input data, and then you'll see how that reflects here. I'll send it in the test network. I'm going to use Rinkeby test network, so I don't spend any money on gas. So firstly, I will just as I said, what's displayed in the ETH transaction is in hexadecimal. So I'll just say hello Krakens in this web page, and it'll translate these characters into hex, which is what we're putting as input. So we're going to copy paste this value here. We're going to go to MetaMask or Rinkeby test network. We're going to send money to myself. We're going to send 0.01 ETH, and then we're going to put here hex data, our input. It has to start with 0x, and then I'll command V and put my input. If you don't see this hex data on your MetaMask when you're sending transactions, it's probably because you have to enable it. I think if you go to settings and advanced options or advanced settings, you can see a little switch for enabling or not hex data input. In my case, I have it enabled. So I'm gonna send this transaction. It's gonna cost me this amount of gas, but I'm on the test network, so I'm not really spending US dollars. It's sending. We're gonna go to the block explorer here. It's pending. I think I should get a notification somewhere here soon. When that's mined, and then we're just gonna inspect this transaction and see if it actually reflects our input data. We'll refresh. It's still going. I think it's identified this block and the amount of ether and how much Gwei I'm planning to spend. I think this shouldn't take much longer. If I refresh, okay, cool. So success. There's only been one block put after mine. And so if we go to click here to see more, we'll get all the details of my transaction here, and then you'll see input data, which is what I put, but you're seeing it in hexadecimal, so no human can read this, obviously. So we can convert it to UTF, and you can see here, hello Krakens. So you can, this is to say that you can, a transaction also holds any sort of input that the sender is wishing to send to a receiver, which in this case, from and to are myself. But for demo purposes, you can see here that this is some neat thing that you can do if you didn't know already. So that is that. And I'll just quickly end. We're about 40 minutes in. I'll probably take a couple more. From the last webinar that I did, a lot of people didn't know how or were appreciative of minting from contract. They didn't know how to do that. So I'll just quickly tell you how to do it. Instead of going to a web page, a minting web page or a front end, if you want to mint directly from the contract, that's usually slightly faster than going to the web page. If you're participating in a gas war or want to mint a crazy collection, usually bots go to mint from contract just because it's slightly faster. And if I go to the Kraken's collection, for example, what you need to do is find the contract address. I'll just grab any Kraken. This is pretty fun one. We'll go to the Kraken's contract address, and again, everything's public. You can see all the mints here. But if you go to the contract code, again, everything open source. You can look at it. To mint from contract, I'm not gonna actually do it right now. But every ETH smart contract should have a mint function, and it receives two inputs. One is how much ether are you putting towards this mint, and how many NFTs do you want to mint. So last webinar I minted actually 10 Krakens. You can probably see them right here in my wallet. These are my 10 Krakens, and I minted them from contract. So I paid 0.66. It's even pre-recorded here, and I minted 10. So I would put, that's the amount of ETH I'm willing to spend for 10, and then I click write, and that directly writes to the contract, and I would get 10 NFTs back. Cool. So that's for those that didn't learn that last time or that are new for this webinar. Again, just to recap, we kind of went over everything that a transaction has, all the input it covers, went through kind of the code as well, learned what this KCHAC 256 algorithm was, and went through what a transaction fee was, base fee, miner fee, this new protocol implemented last August in the Ethereum network called EIP 1559. And then we also finalized by sending some input data through a transaction, converted it to hex, and then converted it back to ASCII for readable human format. And then we saw it right here. Hello, or another one. Hello, Krakens, I think. Hello, Krakens, this one right here. And then I just kind of quickly went on to ask how to find a contract, smart contract for any NFT collection, and how would you theoretically go ahead and mint it. Before I go to the chat for some closing notes and maybe some closing comments, I'm starting to do these webinars, and I'd love to hear any type of feedback that you might have. As I said, I'm kind of mostly on Twitter, and I recently kind of posted this. If you could share, if you were in here and then you enjoyed kind of stuff that you learned, I'd love to know one thing that you learned, and any feedback that you might have on the presentation, good or bad. I'd love to hear from every single one of you if possible. And then after I read you, I kind of know what to improve on, what you like to learn, and so I can double down on the stuff that you guys are liking or that in general this presentation is giving you value. So definitely would like to hear some of that, um, to help me understand a bit better how to deliver more value to you guys. So if you go to Daniel Belfort, it's the last tweet that I had posted here. That'd be awesome. Thank you. I'll go to the chat. I don't know if there's any questions. I haven't really checked it in a while. Awesome. Great job. Good evening, Krakens. Hey, everybody. We're just finalizing this webinar for those of you joining. I think it's recorded. I believe it's recorded. We'll share some of the snippets probably soon. I hope you guys enjoyed it. I'm starting to do this more often. So again, if you have any feedback for me, that'd be super, super great. That'd be awesome. I'd really appreciate that. Is it possible for devs to disable the mint function? I believe so. Um, I believe so. So if that right button is grayed out, then that might be the reason if you're trying to do it. Thank you, Fitmot Glam and Supra Tim, Surfer Kiddo, Ratty Kraken, all you guys. Thank you for leaving your note here in the chat. I don't know if there's any questions that might have popped up. If so, let me know. Let me know. I'm all here for it. Cool. Yeah, yeah. I don't know, guys. If all good, I'll just probably hang one more minute here. If not, drop me a note on Twitter. I can maybe answer any questions there if you're still digesting some of this. So I hope this was valuable to some of you. You learned anything, that is awesome. That's really all I strive for. Yeah.